We're going to be talking about scaling service mesh across clouds today. I jumped ahead and did the whole intro thing started. So who am I? My name is Cody De Arkland. I work for Kong. The original session you signed up for showed me as a principal product marketing manager. I just had the opportunity to move into our office of the CTO as a technical marketing engineer. So I'll be building technical content around how Kuma and Kong Mesh kind of work and how they solve actual problems inside of environments. So I'm pretty excited for that. I'm really passionate about the technical marketing space. You can find me on Twitter. If you ever have questions about Kong Mesh, Kuma Mesh, technical marketing in general, kind of career stuff, I love engaging with people in the community. I'm a big believer that communities build careers. So if you ever have any questions or any way you want to engage, please reach out on Twitter at Cody De Arkland. I respond much faster there than I do to Slack or email. So the best way to get a hold of me is on Twitter. Next slide. Loading. Quick plug for a session we're doing in a couple of days. We're going to be going through observability in a service mesh. Kong Mesh and Kuma Mesh have a fantastic kind of observability take in the way that we approach tracing, as well as kind of Grafana and metrics visualization. So we'll be diving into that and taking you on a tour of how that works against the demo app that I threw together. So join us, come hang out with me. You'll hear good jokes or bad jokes and fake laughter. So it'll be a great time for all of us. So I'd like to start off my presentations with kind of questions just to get everyone thinking and kind of positioning their mind around what we're trying to do here. Service mesh is such a bogged down term, and it's used in a lot of really kind of creative ways. There's nothing wrong with the way that people necessarily use it, but I just think that it's become a pretty vague term that describes a whole lot of things. I like to think of service mesh as application first connectivity. I'm an app guy historically. I'm not a networking guy. I generally avoid networking, which is kind of odd how I ended up in the service mesh space. But I think it makes sense when I frame it around the application. And because really what I cared about and what I always kind of positioned was the fastest way to get applications in front of people. And that connectivity part is a part of that. So when you think about service mesh, start to ask yourself, is it really service mesh, or is it a way to approach application networking that's kind of different and more evolved than what's been in the past? And now that we have that kind of definition queued up in our head, when we think about the way a service mesh works, historically, we've seen a lot of service meshes address connectivity within local environments. So I have a service mesh running in each one of my different Kubernetes clusters. But what we're seeing is this evolution inside of customer environments where that connectivity is actually more of a global construct. And what we want is the ability to have a central way. Notice I'm avoiding central pane of glass. This isn't a central pane of glass solution, but what we look at is a central way to kind of manage and orchestrate that connectivity between resources and between applications and environment. And I would argue that a true service mesh should be focused more on how to do this globally as opposed to how to do this individually. We can certainly do the individual use case. And I think that, frankly, that is a much simpler problem to solve when you're just throwing a service mesh in each cluster and calling it a day. But I think that the more appealing solution is when we start to stitch this together between kind of these remote environments. And when we have that vSphere cluster trying to connect to resources that live up inside of AWS, like how do we stitch that together and how do we create a service mesh that really addresses that problem? So let's jump forward a little bit. I talked about this a little bit, or I talked about this just a moment ago a little bit. So why run global? What does that really get you? You know, a couple things that come to mind. There's a lot of like architecture out there around why run global and faster agility and all of that. But I like to think of kind of practical outcomes. I think of things like self-service. And I think that service mesh is really interesting because it really brings that self-service concept to service mesh or to application networking. So self-service management of application connectivity, that's routing, that's moving of traffic between environments, that self-service concept. We have centralized policy management, and think of policy in the bigger term, right? I think of policy as, do I want 50% of my traffic to move between these two versions of an API service? How do I want the routing to look like? What do I want my retry parameters? If I have OPA engaged, like Kong Mesh supports out of the box, what are my OPA policies associated with that? Having this run globally is a way to have that policy applied at that global layer and trickle down to the environments beneath. And then global scale of operations. I'm a huge nerd when it comes to scaling operations. And I think that we talk about scale all the time. And again, architecture. when we talk about scale, we always talk about 10,000 pods in an environment. But you know what? Scale also applies to me and 5 of my admins trying to manage an environment. Scale is how we interact with the system as well. So there's definitely a component of how big can you make an environment, but there's also the difference between Cody managing an environment, and I'll grab a couple names, Mark, Martine, and Scotty Ray, as well as Cody, all managing environment. That's a different kind of scale. And what having this global control plane does is enable a better way to have that global scale of operations. So why Kuma? Why Kong Mesh? Kong Mesh is the enterprise version of Kuma. So Kuma is an open source CNCF project that we contributed, or that we donated to the CNCF and we heavily work on still. Kong Mesh is something we take a couple of enterprise specific features and layer on top of. Globally connected, we've harped on this a lot. I'm not going to reiterate it. We really want a service mesh that operates well globally. Run across any platform. We have a great user experience for getting up and running on virtual machines, on Kubernetes clusters, on Fargate instances, and ECS, right? We're really focused on making that service mesh consistent amongst all of the platforms you run on. The last one, it sounds like I'm being very markety. Again, I keep taking shots at the marketecture thing, but my personal opinion is the thing that's held service mesh back from widespread adoption is the user and operator experience. I think that Kong Mesh and Kuma really nail that user experience and make this a consumable platform. And I think when you look at the operating patterns of other meshes, it's not that they're wrong. It's just that they're focused on a different set of problems. We really want this to be operator, developer, architect friendly so that operators can get in and start using this in a way that makes sense. It's why we have the API-driven approach, as well as the Kuma control-driven approach, as well as the CRD approach, right? We make sure that we have a number of avenues that you can interact with. The user experience is great from looking at the environment, from getting up and running with metrics, tracing, getting the control plane even installed, right? We focus a lot on user experience, so I would advise you to keep an eye out on that as I run through the demo. We're going to go from the ground up on this demo, so you're going to see a lot of it. We're going to speed this up a little bit because you have about 15 minutes for me to crank through. It's about 10 minutes for me to crank through. So I'm going to speed up the animations here. Term setting. Global control plane is the central point of interaction. So APIs hit that global control plane. I'm running that on my Synology NAS in my environment today. Typically, you'd throw that either on its own Kubernetes cluster, a virtual machine. It just needs to live somewhere. It's a central authentication or central entry point for API communications. It's pushing down the configs to things like the services and the Envoy instances. It's orchestrating those Envoy configurations at the application endpoint. We have a Kuma DNS that runs inside that helps with resolution of resources in a local zone. And then we have the ingress. Ingress works a lot like a gateway that allows traffic to come inbound, so the other instances know about those ingresses and can pass traffic to those different resources. So that's a high-level architecture. We can dive in a little bit more in the Q&A later if anybody has questions. Oops, back one. This is a brief topology of what the environment's going to look like. We'll have my global control plane running on my NAS. We'll have my vSphere cluster as one remote endpoint, and then we'll have the Amazon EKS cluster running as another endpoint. Let's get to the code. Like any good magician, I'm a big believer in showing that things aren't working first. So you'll see me spamming the refresh button. This ain't connecting. Let's go ahead and bring up that remote control plane. If we scroll over, you'll see I did some early prep work to make sure that things weren't too broken. I've got my database set up here, and that's just a freshly instantiated database. There's no data in these tables yet. It's just a fresh database. So I'm going to go start. I'm actually going to be running Kong Mesh, so I apologize that my service is called Kuma. It's actually Kong Mesh in this case. And what we're going to do now is I'm going to cat the log for Kuma. So what we'll do is we won't cat that. We will tail it. So the mesh is up. If we switch back into the UI now and hit a refresh, we're up. We've got a license applied. We're running in universal mode, which means we can accept virtual machine clusters as well as Kubernetes clusters. And we're running in multi-zone mode. So let's start bringing some things in. So we have this KDS token that was created. So I'll switch back over to my Getting Meshy tab. Now, if I go into kubectx, we can see I've got my vSphere cluster, my EKS cluster here. The other one's just my cluster API cluster for provisioning out additional clusters. So we're in vSphere. And what we're going to do, let's make sure that everything got cleaned up from my previous runs. Awesome. See, I'm running Cilium for my CNI in there. This is a vSphere cluster. You can see a CSI nodes running there. So we are going to do, I have my values file here for my actual Helm install. So these are all the configurations for my install. I'm doing a cool trick here where I'm using my external IP from my lab environment and I'm natting it inbound to the ingress that's created inside. So that is why this looks a little funky here. So we are going to go Helm upgrade. We're going to cheat and do autocomplete. So you can see I'm hitting my vSphere cluster. We'll go ahead and run that. I didn't create the namespace, so hopefully I didn't. Yeah, see? I thought that I had already created that. Try again. So that is running. If we do, you can see these coming up online right now. If we go back in the control plane, we can see some stuff is happening. We've got a new peer. Data planes are coming online. Life is good. If I go in here and hit our data plane object, so data plane is how Kong gets information from the control plane. So we see this data plane has come online. We switch back in. It's the wrong way. Boom. We have our control plane up and running. We're going to go ahead and create our namespace. Oops, we're actually going to just actually, let's switch over to that direction. There we go. So we have a Kong namespace in there. And if we look at that namespace file, all this has in it is just selling anything that goes in here gets a sidecar. So that sidecar, data plane, right? So that sidecar that comes up is the data plane object that gets registered into Kong Mesh, Kuma, and all of the connectivity, policy, traffic information gets pushed down onto that. So we are up and running now inside of here. Just because we're in this cluster already, we're going to go ahead and apply a couple of our app things. So if we look in my directory here, we can see I've got a couple of different YAMLs. We're going to go ahead and apply the API YAML. We're going to apply the DB YAML. And we're going to apply the Redis YAML. We're going to hope that nothing breaks. Hopefully I didn't push any weird changes at the last minute. Why do I see two pods here? One is the running application. The other is the data plane, right? So the data plane is effectively Envoy getting its configuration from that global control plane. Global control plane comes down and connects in and dumps that config in. We can verify this by going into logs, Kong Mesh System, and we'll just grab API as an example. Actually, not Kong Mesh System, sorry. Kong API. And if I hit enter, it'll fail because it wants me to pick API or sidecar. So if I went Kuma sidecar, things are starting to pick up. That's just the initial run. Not to worry too much about that. Those are still coming up, so that's why it was failing for a while there. There's one thing that I forgot to do real quick, and that's because, or in order to enable the global configuration, we need to apply the MTLS configurations. So MTLS is needed for cross-zone communication. So I'm going to use Kuma control on my global control plane and apply that. So if I go in here and you want to see what that looks like, this is simply just initializing the default backend for the MTLS configuration. So we have assert authority doing certy things. Go back in here and make sure we're not seeing anything terrible. So that's done. Everything's up and running in here. we are running a little short on time, so I'm going to quickly switch over into here. And what we're going to do is cheat and grab my most recent command. I used Helm for the on-prem one. This time I'm going to use Kuma control. Actually, first I'm going to make sure that I use the right version. Yep, so I'm using Kong Mesh 1.4. So Kuma control install is going to install a control plane as a remote. It's going to call it EKS. It's going to have ingress turned on. It's going to connect to my lab over this address. And then I turn on a DNS configuration in that environment. Whew. Lots of things and stuff happening. This is starting to come up. I'm going to go ahead and apply the namespace file over here as well. Switch back into the UI real quick. Do a refresh. We should see that ingress coming online in here in a moment. Just hasn't started yet. If we go into our zones, we can see EKS. You can see both zones have registered. Come on, little ingress. There it is, starting to come up now. Now, we're going to have a little bit of a hiccup here because this AWS ingress takes a little while for that load balancer to become a real boy. So it takes a little while. We are now on this side of the environment going to apply our application. That might start to fail as the ingress hasn't come up yet, so it hasn't gotten to a point where it can start to connect. Actually, it didn't. So if we go in here, and we look at this, the applications come up. And what's interesting about this is this application will only come up if it can connect to the environment. So we're going to go ahead and install real quick, see if we can get it going in time. All right. That's Kong's ingress gateway coming online now. We're going to apply a entry point YAML. So you can see what that is. That's just saying front React is the internal service name, so that it's called front. And then we're going to apply this ingress that's going to allow connectivity to it. Words are hard. Should be able to knock this out in about a minute here, and then we can get to Q&A. I'm certain this is going to fail. Yep, because it just takes a little while for that load balancer to come up. So we are going to cheat. What we'll do is give it one more refresh. Yeah, it's not going to work. Things are still coming to life in there. For the sake of speeding along, we're just going to forward straight to the pod. It takes a little while for the initial configuration to finish the connect. So let's do it like this. In a few moments, this will should, in theory, finish connecting. So we have our API up, and it's just taking a few to go across. So that API, the database takes a little while to initialize the first run, so that's why that hasn't connected yet. Oh, there it goes. So what we're seeing now is an application come inbound into AWS and ultimately reach resources that live in a completely different zone. Now we could deploy another version of the API tier and start to play with traffic policies to move versions. I call this, or I don't call this progressive delivery. That came from a guy named James Governor at RedMonk. But progressive delivery is the idea of how we deliver applications, and as we deliver them, progressively bring them online. So I use traffic splitting to do things like that. And it's really one of my favorite examples of cross-environment service meshes, because as we start to bring in new applications, as we start to bring in new versions of applications, we want intelligent ways to bring those online and to bring those into connectivity and be able to interact with them. Another cool test that I can show is I have Insomnia running over here. And if I change this environment variable for my demo application, if I change this to what we'll do is we will go, I'm looking over for Q&A questions. I'm not seeing anything yet. I'm not seeing anything yet, so I'm going to keep going. Real quick, let's see if the load balancer came up yet. There we go. It did come up. What I was going to show is taking this entry here. We'll replace it in here. This environment now will get passed into my subsequent API calls. And what we're going to do is we're going to go ahead and post a new user to the database. It'll take a few moments because that ingress just came online. So I'll bet it fails in about 10 seconds because, oh no, it actually took. So this is an encrypted password. Now, if I switch back into the application, we'll bring up the log so you can see it pass or fail. Our session's just about over. Just want to verify that it works. Waiting. A little bit of a timeout issue there. All right, so the login's taking too long and it's failing because the ingress just came up. So either way, we're at time. So I appreciate everyone stopping by for the session. I hope you enjoyed seeing how we can take Kong Mesh and Kuma and stretch them between environments. I'm definitely around on Twitter. Ask me any questions. I'm happy to answer anything about this.